actually the users of the trusted framework will not be much concerned about the internals, how this is implemented. But of course, something that you should be aware is how this trusted framework will be deployed, because this has actually an impact on your activities wherever you are in the project. So first of all, let me say that the trusted framework is an infrastructure. It is a collaborative network, and it is composed by several nodes, which are called trusted nodes. You can see them in the picture. It's right in the center, and basically each trusted node corresponds to a company, because in a supply chain, and the trusted framework reflects this, the atomic element is the company. You have several companies, and so each of them is represented by a trusted node, which is quite a complex system that you can see on the left-hand side. I will explain that a bit more in detail later. The two things that I want to point you to in this picture are that firstly, all the trusted nodes are organized into clusters. A cluster is something that is entirely virtual. It's not a physical thing, but it is a way for ensuring data confidentiality. So inside the cluster, all the trusted nodes has the same visibility over data, and there is no visibility on data at all across clusters. And so clearly this means that ideally, at least, we have a mapping of the cluster to a supply chain. And this is what I've said before. We have a shared infrastructure that can support several supply chains at the same time. This is important because in this project, we are going to provide the infrastructure as a service. If you remember, I told you in the introductory workshop on seminar on blockchain technology that blockchain, the main reason for its existence is that every participant in the system has its own node. So the nodes can control each other. That's the reason why this is a trust enabler. And so normally there is no reason for having a blockchain that is provided to you on the cloud as a service by someone. The only exception to this rule is when you are doing experimentation on blockchain technology. If you are doing experimentation, it might be a bit too much for you as a user to deploy and operate your own node, which might be difficult, might require time and resources for doing that, even knowledge. You might lack the knowledge for doing that. And so in the context of a research project like this, it makes total sense that we provide, my company, and also with the collaboration of Tributech and Inlecom, we will provide this on the cloud, so you're not going to operate your trusted node. However, what you will have to operate, but this is extremely lightweight and you don't need any special knowledge for doing that, is the personal node. The personal node is a program that you will need to install on whatever system needs to integrate with the trusted framework. It's a sort of gateway, and it is called personal node because it represents the identity of an actual user. So the personal node is not shared between different users. It is personal. Each user will have its own personal node. If in a company you have 3 different users, like in this example you have 2 humans and 1 smart machine connected to the trusted framework. It's just an example. I mean, I'm not advocating that we should have smart machines that are integrated with the trusted framework at all, but in case all of these users will have to run their own personal node. Now, in detail, what is inside a trusted node and inside a personal node? Well, a trusted node contains a blockchain peer node, first of all. And this is what you see here in this gray box, which is called the ledger node. And in fact, there are 2 services there. Not going into detail here because it doesn't make any sense in this context, but basically what we are managing in the ledger node are the metadata of the quality hallmarks, and this is the trace service. And then all the identity management stuff is done inside the IDM service. And this is the blockchain part. And so this is based on smart contracts, and the smart contracts are providing an API, but this is an internal API. So you will not be required to integrate with this API. The data node inside the trusted node is something that has nothing to do with blockchain technology. This is where the storage is actually done. We are storing data here. We're storing metadata in the ledger node and data in the data node. And this is a technology that will be synchronizing a DB, basically a database, a local database, and we will have multiple copies of this database, 1 of each trusted node, and so basically 1 for each company. As I said, all these APIs are internal. So applications, devices, and systems, legacy systems that need to be integrated with the trusted framework will be using the green box that you see below, the so-called Trusted Framework Open API. The Trusted Framework Open API will be simple to use because it will be a REST API over HTTPS, and we already have a very simple draft of this API available. It is not out there in 1.4, in delivery of 1.4, but it will be in 6.3 in a short time. But this is just the baseline for our discussion, because I strongly suspect that this API will change according to the requirements that we will collect during our collaborative work. And one more thing about the personal node. As you can see, there is also an identity wallet inside the personal node. This means that inside the identity wallet, the user will have their digital credentials. So the credentials that are used to authenticate the user identity with the trusted framework. as we will see later, because we are going to discuss very briefly the identity management layer, this is all based on a public key infrastructure. So it's not that you will need a username and password for identify yourself. It is based on the possession of a key pair, so a public and the private key, and the private key will be stored inside your identity wallet. The interesting thing here is that it is a wallet, so it implies that you can have more than one identity there. If for any reason you are the owner of more than one identity, you will have one single personal node, and all your identities will be stored inside your identity wallet. There will be a tool that is released to you to manage the wallet, but you can only use one identity at a time. So you can switch from one identity to the other, but the personal node will be impersonating one identity at a time. And through the personal node, you will be able to use the services of the trusted framework, which is, let's say, the data management, the DM client, and also the identity management. So the personal node will provide functionality also for managing the identities, not only the quality hallmarks. Okay, so let's skip this because it doesn't matter much, the internals of how this is done, the relationship between the trace service and the data service. Okay, this is something that I already said, so I probably moved a little bit forward in my explanation, but this is the slide that points to the role of the personal node as the impersonator of a user. As the personal node doesn't know what is the identity that needs to be impersonated, and also because the Open API is a REST API, from an operational point of view, every time you or the application you are using will call something, will call the Open API, they will have to provide as part of the parameters of the call the actual identity ID that they want to use, and also the decryption password for the identity wallet on the personal node, because the identity wallet, for obvious reasons, is encrypted, and the user is the owner of the encryption, so it will be encrypted with the password, and the password will never be stored inside the personal node, something that the user will be responsible to keep secret, and so it will be needed for the personal node to access the identity wallet and get the credentials that are used to authenticate this identity with the trusted node. Okay, so about identities. Identities in the trusted framework are quite a complex subject, because they are not. It is not a flat data space. So it's not just a list of users. There are hierarchies, and so we have a parent-child relationship in identities. This means that, for example, we start from the identity of a cluster. So each time we want to define a cluster in the trusted framework so that we can create a separate data space, we will have to define an identity that typically will correspond to the, will be owned by the leading company in the supply chain. Then for each of the companies that belong to the same cluster, there will be another identity, and all these identities will be children of the first one, of the cluster identity. This hierarchy is captured inside the Trusted Framework identity management system. And the same is true for the individual user identities, because of course every company has its employees, every company will have its machine identities if they have smart machines. And so this will be identities that are children of the company identity. The interesting part of the story is that from the management point of view, the management perspective, this is not something that is done centrally by some administrator. There is a complete delegation of responsibility. And so, for example, we will have the cluster identity, which is actually released. It is created and released on the ledger by an administrator. But then the owner of the cluster identity will be totally in charge of creating and managing the company identities. So we expect that the companies will ask to the cluster manager to be registered on the identity management system. And once they are registered, they will have their own identity, so they will be able to do the same process for their own user identities. And this is basically what we mean by decentralization when we talk about identity management for the trusted framework. Now we have some slides that try to go into more detail on this, but I have been advised against delving into details about this, so I will skip very quickly across these two slides. One thing that I really want to point out, because I think that this might have quite a significant impact on our choices later when it comes to defining how the quality hallmark process will work, is this, that this is basically the hierarchy that I explained to you just now. We have one company in this example, which is Acme Systems, that is the leading company. Then we have some participants to the supply chain, and then we have the employees, the machines, and so on. But we can also have other kind of parent-child relationships, and this might come useful if we want to leverage on this identity management layer, also to identify the targets of the quality management process. So we can as well create identities that represent products, that represents parts, that represents processes, that represent product types, so classes of products. And again, this is something that is very flexible because there is a delegation of responsibility. So one company, for example, CNC, the one in the middle, if they have product parts to be registered on the ledger, they can do that themselves, because these product parts will have a parent-child relationship with their own company identity. So it means that the manager of the company identity can as well create identities for the products of that company. The reason why we might want to do that is that once we have a registered identity for a product, we can create links and references to this identifier inside our quality hallmark. And it is important that we have a common understanding of what we are referring to in a quality hallmark. So this is the message that I am trying to convey to you about the advanced use of digital identities in the trusted framework. And that's all for the identities. Now, very briefly, I just want to show you what is the current state of the OpenAPI. We have an identity management API, which is basically done because this is actually an asset that my company is contributing to the project. So it is an existing system. It is unlikely that we are going to change it in a significant way, because I think it is quite to the point. I mean, I don't see any reason for introducing new functionality, but in case it is, in theory, it is possible. But it is a very simple API that is based on identity descriptors, and the identity descriptors are something quite flexible. So the only not flexible part is that we have a unique identifier for the identities that is basically generated in a random way. So it is a string, but it is not a human readable string. It is not a name. It is something like a UUID. And then in the descriptor, we actually have all the details of who or what is the real world entity that is described here. Okay, instead, the quality hallmark management, it is a work in progress, and currently, as I said before, it is based on an assumption that is probably wrong. This assumption is that the quality hallmark document is something that is composed externally once and for all by someone, which might be, I don't know, the Work Package 2 subsystem. And then it is published. And once it is published, it can only be retrieved either because you know its ID, but you can also search for something that you know is on the ledger, but you don't know exactly what the identifier is, and you can do that either by specifying the owner, so you can retrieve a list of all the quality hallmark documents that belong to a given owner, but also you can specify search criteria, which is much more interesting. And this is quite a complex topic that we will try to explain later. So this is the introduction to the quality, to the trusted framework. And I would now stop for a short question and answer slot after we start the interactive part.